Okay, numbering systems. We're going to talk about decimal numbering system today. From the time you were very, very young, you were taught how to count in the decimal numbering system, counting on your fingers, and they taught you how to count and say the words when you counted, so you could count things like marbles. And I'm going to just draw some marbles here. So we've got 5 marbles there, and then 5 marbles over here. So just about like your fingers, and you were taught to count 1 through 10 like on your fingers. So then you got to school. When you went to school as a little kid, they started teaching you how to count with symbols, and they showed you the symbols that went along with the sounds you were making to go with the objects. So we had 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so you went from single-digit numbers up to 2-digit numbers, and you learned to count from 0 to 9, and then 1 0 to 1 9, and 2 0 to 2 9, all the way up to 9 0 to 9 9, and then we had to roll over again. We had to add another digit, so we went 1 0 0. So you learned each time that you added a digit that it was 10 times the value of the previous digit. So, and if we take a look at a number, let's take a look at just about any number, but I'm going to write down a number here. Let's take a look at 5,495. So, and sometimes we put a little comma in there to keep things straight so we know where we are, know how many digits there are. But the rightmost digit, this rightmost digit right here on the right hand side, is in the ones place. This is the ones place. So that's how many ones you have. And then the next digit is how many tens you have. And the next digit was how many 100s you had. And the last one here on our number is how many thousands do we have. So you learned how to do this at a very early age. So the reason that these go 1, 10, 100, 1,000 is that this first digit is 10 raised to the 0 power. 10 raised to the 0 power is equal to 1. So the second digit is 10 raised to the first power, which is equal to 10. Anything raised to the first power is itself. Anything raised to the 0 power is equal to 1. So it doesn't matter what the number is. If you raise it to the 0 power, it equals 1. Anything raised to the first power is equal to itself, and the next digit would be 10 to the second power, which is 100. 10 to the third power is 1,000, and so on. It continues on, right? So, so to value this number, first we're going to count up. You count up how many ones do I have. You look at this place right here, in the ones place, and you'd say, well, I have 5 ones. 5 ones. So if we were counting dollar bills, you'd say I have 5 $1 bills. I have 9 $10 bills. I have 4 $100 bills. And I've got 5 $1,000 bills. So And you would have to multiply these out then until you got 5, and you got 90, and you got 400, and you got 5,000. So, and then you would add those up, and when you add them up, you would get 5,495, just like we already had, right? So, so that's how the decimal system works, and you already knew most of this, right? You already knew all of this. So, since this is the system you've been using all your life and you know it extremely well, this isn't news to you. What you may not know is that the decimal system is also called base 10. We're going to introduce a new word here. We call it base 10. And if we wanted to signify that a number was in base 10, we're going to put a little 10 as a subscript in the lower right part of the number there. So that shows us that we're counting in base 10. We do this all the time, and it's our default numbering system, so we don't even bother to put the 10 down there because everybody knows that we're already counting in 10. So every numbering system has the same pattern though. So if we take a look at another numbering system, if we take a look at the binary numbering system, binary, the BI at the beginning of binary means it's made up of two parts, so but it is equal to base 2. So binary is base 2. And since it follows the same pattern, then the first digit in any binary number, the rightmost digit, is going to be equal to 2 raised to the 0 power. The next digit is going to be 2 raised to the first power, then 2 raised to the second power, then 2 raised to the third power, and it follows the same pattern as we saw up here with decimal. Okay, 2 raised to the 0 power is equal to 1. Anything raised to the 0 power is equal to 1. 2 raised to the first power is equal to 2. Anything raised to the first power is equal to itself. Then 2 raised to the second power, or 2 squared, is 4. 2 cubed, or 2 raised to the third power, is equal to 8. So the first 4 places in any binary number would be the 1s, the 2s, the 4s, and the 8s. So if we had a number, for example, 1, 1, 0, 1, that would mean that we have 1, 1, so we could count that. We don't have any 2s, so we wouldn't count that. We have a 4, so we'd write down a 4, and we have an 8, so we write down an 8. Then if we added all these together, we would get 5 plus 8 is 13. So 1, 1, 0, 1 in base 2, or binary, is equal to the number 13 in decimal, which would be base 10. So we saw that little subscript before. So this number up here is in base 2, so if we put the subscript down there below that number, we would see that. So each time you add another digit, you increment the exponent and you move up. So the next set of digits for binary would be 2 raised to the 4th power is going to equal 16. 2 raised to the 5th power would be 32, 2 raised to the 6th power is 64, and 2 raised to the 7th power is 128. So if we had an 8-digit number, such as 10110011, okay, now this is base 2. We're in binary. So, and we saw how we've got 1s and 2s and 4s and 8s. Now we're going to look at the rest of it would be 16s, 32s, 64s, and the last digit on the end here would be how many 128s do we have? So, well, you can only either have one of those or none of those. Those are your only two choices in binary. You either have one of those numbers or you don't. So if we look at this number and then added up the digits, we would have 1 in the 1 spot, so we have a 1. We would have a 1 in the 2 spot, so we have a 2. We don't have any 4s, there's a 0 there. We don't have any 8s, there's a 0 there. We have a 16, so we write 16. We have a 32, we write 32. We don't have any 64s, there's a 0 there. We do have 128, so we would write 128 over here. So, and then we would just use basic math to add all these up. We've got 2 and 1 is 3, and 6 is 9, and 2 is 11, and 8 is 19. We would carry the 1. 2 and 3 is 5, and 2 is 7. And we would just bring the 1 down. And in base 10, this number equals 179 in base 10. So congratulations. You just converted a binary number into a decimal number. And we'll go on from there.